Today our concern is about the parallel computer memory architecture. So first of all, in parallel computer memory architecture, we have the shared memory. What is shared memory? So when the all processor access all the memory as global address space, like multiple processes can operate independently, but they are sharing the same memory resources. So when the changing in the memory location affected by one processor, so it will be visible to all the other processor. That's the concept of shared memory. So shared memory machines are classified as UMA, NUMA, and based upon the memory access time. Let's discuss what is UMA. UMA stands for Uniform Memory Access. In most commonly represented by the systematic multiprocessor machines. They are the identical processors. They have equal access and access time to the memory, and sometimes they are also called CCUMA, which stands for cache coherent uniform memory access. What is cache coherent means? It means that if one processor update a location in the shared memory, so all the other processors alternatively known about the update. So cache coherent is accomplished at the hardware level. Next, we have NUMA, which stands for the non-uniform memory access. It often made by the physical linking two or more SMPs. So when one SMP shared memory processor can directly access the memory to another SMP. So not all processors have equal access time to all the memories, and the memory access across link is slower. So if the cache coherency is maintained, then they may also call the CCNUMA. Cache coherent NUMA means cache coherent non-uniform memory access shared memory. What are the advantages and disadvantages of the shared memory? First of all, we have advantages. Let's discuss it. So it's a globally addressed space, provides a user-friendly programming perspective to the memory. Second, we have the data sharing between tasks is both fast and uniform due to the proximity of the memory to the CPUs. Next, what are the disadvantages? Primary disadvantage is the lack of scalability between the memory and CPUs, which means that adding more CPUs can geometrically increase the traffic on the shared memory CPU paths, and for the cache coherent systems, geometrically increase the traffic associated with cache or memory management. Next, the programmer responsibility for the synchronization construct that ensure the correct access of the global memory shared, which is difficult task for the constructor. So which actually for the programmer. Next, we have the second memory, which is first one we have discussed shared memory. Second, we have the distributive memory. What is distributed memory? It's the processor has their own local memory. In shared memory, actually we have the processor we shared. So when the work performance on one processor, it is shared on all the processor. But in distributive memory, each processor have their own local memory. When they changes to the processor's local memory, they have no effect on the memory of the other processors. So when a processor need access to the data in another processor, it usually tasks of the programmers to explicitly define how and when the data is communicated, which is a difficult. So synchronization between tasks is likewise the programmer's responsibility, and the network fabric used for the data transfer varies widely. So though it can be as simple and as Ethernet. What is advantages? Advantages that the memory is scalable with the number of processes, and each processor can rapidly access its own memory without the interference and without the overhead incurred with trying to maintain the global cache coherency. What are the disadvantages? That a programmer is responsible for many details, and in a non-uniform memory access time, that the data residential and remote node takes longer to access than the node's local data. Last but not the least, we have the hybrid distributed shared memory, which is the largest and the fastest computer in the world of the today's employ both shared and distributed memory architectures. So the shared memory component can be shared on the memory machines or the graphic programming processing units, and the distributed memory components in the is the networking of the multiple shared memory of the GPU machines. What are the advantages and disadvantages? That whatever is common to both shared and distributed shared memory architecture, it increases the scalability, and it increases the programmer complexity, which is an important disadvantage. So that's for it today.